Okay, so we're on 7-3, and this is more exponent rules. So if you look at the first thing, we know way back from chapter 1 that if you have 2 to the third power, that is not 2 times 3, okay? That's not 6. 2 to the third power, that means 2 times itself 3 times. So that's actually 2 times 2 times 2. All right? So then if we look at this one right here, if we have 3 squared, that's going to mean 3 times 3. And if we have 3 to the fourth power, that's going to mean 3 times itself 4 times. So that's going to be 3 times 3 times 3 times 3. Well, then if we were going to multiply those two things together, like right here, well, what would that mean? Well, that would mean, well, the first one would be 3 times 3, right? And the second factor in that product would be 3 times 3 times 3 times 3. So this one right here is, that one is 3 squared. And this one right here is 3 to the fourth. So then what do we end up with then? 3 to what power? You guys got to unmute. Well, we're going to end up with 3 times 3 times 3 times 3 times 3 times 3, right? So what's that? 3 to what power?
3 to the 6th power.
Thank you, Jackie. Yeah, that's 3 to the 6th power. So we're going to end up with 3 to the 6th. So then what did we do with the powers then, or the exponents? What did we do with these two?
We added them.
Very good, yes, we add them. So that's what we do with the exponents, we add them. So we'll write that in on this blank right here. So add them. So then if I wrote you a rule for this, it would look something like this. If you had a to the m power times a to the n power, well, notice you have like bases there, right? The bases are both a. Well, then you end up with that base a to the m to the m plus n power. So then that's the rule. Now your book calls that product of powers. That's the name of the rule. So let's look at these 4 examples then. I'll keep that rule on the screen for you guys. See if I can move this down a little bit. There we go. I think we can fit all those in there. Okay, so the first one, we're just going to add the powers. So this one is just going to be 3 to the 2 plus 5 power. So that's going to give us 3 to the 7th. Now, if you got a calculator handy, you probably, or depending on if you're going to use your calculator or a phone, you're probably going to do it like this. You're going to do 3, and then you're going to use this caret key and then put the exponent in. So that's how you'd enter it in your calculator or your phone, most likely. So 3 to the 7th, well, that's 3 times 3 times 3 times 3 times 3 times 3 times 3. So that's a pretty big number. That's 2,187. So this one ends up being 2,000. Oh, let me move my stuff here. This is 2,187. All right. The next one. Well, the next one we can multiply in any order that we'd like. Like if you do 5 times 7, that's the same thing as 7 times 5, right? So you can, that's the commutative property for multiplication. So what we're going to do on this next one is we are going to multiply these two together first because they both have a base of 2. And then we're going to multiply these two together second because they both have a base of 3. So with the base 2, we're going to add the powers. So this power is a 4, and this power is a negative 2. So if we add 4 plus negative 2, that gives us a 2. And then in the green there, we have like bases of 3. So that's going to be 3. And again, we're just going to add these powers. So in that case, we've got 4 plus 2. So that's going to be 6. All right, and then to simplify it fully, I'm going to go ahead and put it in a calculator for you guys. Again, we're just multiplying these together. So if I put it in a calculator, let's see, 3 to the 6th power, that's 729. And then that's times 2 squared. Well, 2 squared is 4, so times 4. So for that one, I get 2,916. All right, on the next one, well, the next one we don't have any numbers. It's just variables. But you can see that you have the same base on 2 of them, right? 2 of those factors in that product are base Q. So we're going to put these together first. We're going to multiply those together first. So that's going to give us Q. And again, since we have like bases, we are going to add the powers. So it's going to be 3 plus 6. So that's 9. And then the r squared, we're just going to bring that down. So that's just going to be times r squared. And that's going to be our answer on that one then. And then on number 4, now we have a product of 3 factors, but they're all the same base. So that means we're just going to add the powers. Well, notice that that n right there, that is n to the 1st power, right? So we're going to do n, and then we're going to add the powers. So we're going to do 3 plus negative 4 plus 1. Well, that's going to give us, what's 3 plus negative 4 plus 1?
0.
Yeah. So we get n to the 0 power. But then you have to remember from Monday's lesson, what's any number to the 0 power?
1.
Yep. So that one's 1. All right. Now the next number is about scientific notation. Well, again, we're going to try to build that in as we go through chapter 7. So let me zoom in on this a little bit. All right, so this number 5 here. This first number, that's already in scientific notation. Okay? So that's 1.86 times 10 to the 5th. Well, that's a big number because 10 to the 5th would be, what's that? That's 100,000. So it's 1.86 times 100,000. But the reason it's already in scientific notation is to be in scientific notation, you need 1 digit to the left of the decimal point, which is right there. But then this second number, that is not in scientific notation. The decimal point on the second number, like if I gave you a number like, I don't know, if I gave you a number like 5, the decimal point is right here, right? So right now, the decimal point on this second factor in this product is actually right here. Well, to put that number into scientific notation, we need to move that decimal point so that there's only one digit to the left of it. So we're going to move it 1, 2, 3, 4. We're going to move it 4 places. So that number is actually going to be 1.5. And then we don't need to write any of the zeros on the right that are to the right of the 5. And that would be times 10 to the, well, we moved it 4 places, so it would be 10 to the 4th. Now, if we had let me show you another one. If we had a really small number, like, if we had like 0.0013, we would still have to move that decimal point so that there's only one digit to the left of the decimal point. So that one would become 1.3 times 10. Well, this time we moved the decimal to the right. So the power, we moved it to the right 3 places, so the power would actually be a -3. But if we hit some more of those later on, we'll talk about them as we go. But let's complete this number 5. All right, so on number 5, we've got to multiply these 2 numbers together. But again, we can multiply in any order we want. So we're going to multiply the 1.86 times the 1.5. And then we're going to multiply the 10 to the 5th times the 10 to the 4th. Okay? This thing is all multiplication, all right? This is a multiplication right here. 1.86 times 10 to the 5th. There's a multiplication in the middle here. And there's another multiplication here. So what this is going to look like then is we are going to do the 1.86 times the 1.5, and then we're going to do the 10 to the 5th times the 10 to the 4th. So if we do that, we're going to use the calculator for this part. So we're just going to multiply 1.86 times 1.5. So for that part, we'll get 2.79. And then that'll be times 10 to the, well, now when we multiply the 10s there, we have like bases, right? So they both have a base 10. So it's going to be a base 10, and all we have to do is use the rule from above. We just add these powers. So 5 plus 4, that would give us the 9th power. And then that's going to be our answer for that one. And then notice that number is in scientific notation because I only have one digit to the left of the decimal point. All right? Now we're going to move on to our next rule. So the next rule we have here is a power of a power. So it's kind of like it's a power raised to a power. Again, if you guys need to stop me, just unmute your mic and give me a shout out, okay? So let's see, this one right here, it says 2 to the 3rd squared. Well, to square something means to multiply it times itself. So what we could do here then is we could say, well, that's 2 to the 3rd power times 2 to the 3rd power. Well, then we could just use the rule from above, right? We have a like base of 2, and then we would just add these powers, right? So that would be to the 3 plus 3 power. So we end up with just 2 to the 6th power. Well, if we ended up with 2 to the 6th power, what did we do to these powers right here?
Multiply them.
Very good, yes. So when you have a power raised to a power, you multiply the exponents. Well, that means this next one, if we use that rule, well, I guess I could fill in this blank right here for you guys right now. So what do we do with the exponents? We multiply them. All right, so we'll use that rule on this one over here now. So now we have 6 squared cubed. Well, since it's a power raised to a power, all we gotta do is multiply those powers. So then that's gonna give us 6 to the 2 times 3 power. Well, 2 times 3 is 6, so we end up with 6 to the 6th power. And again, if you wanna know what that number is on your calculator, that would be 46,656. Okay, so now I'm going to write you a rule for this. So the rule for this would look something like this. If you had a base A to the m power, and then you raise that whole thing to the n power, you end up multiplying the power. So it ends up being a to the m times n power. And again, your book calls that rule power of a power. Actually, that looks pretty bad over there. That looks like I've got a m times an m. That's supposed to be an n. All right, well, I think that's it for that page. Yep, that's it. So turn to the next page. And now we're going to do these 3 examples up here at the top. All right, so here we go. So number 6. Again, it's a power raised to a power, so we just got to multiply the powers. So this one is going to be 5 to the 8th power. Again, 2 times 4. And if you want an answer for that, 5 to the 8th power on the calculator, that's 390,625. So what about number 7? What's the power on that one going to be? You got to multiply the powers. What do you guys think?
5 to the 8.
Pardon me?
5 to the 8.
No, we got that one. What about number 7?
Sorry, I was looking at the wrong.
I got you.
Would it be 0?
Yeah. Yeah, you're going to multiply the powers. So if you do 3 times 0, you just get 0. So this ends up being 4 to the 0 power. And we know from Monday that any number to the 0 power is what?
1.
Good. So this one's 1. All right. Now let's do number 8. So this one, we're going to start out, again, we've got a power raised to a power here, so we're going to multiply these. So that's going to give us a to the 12th power, because 3 times 4 is 12. And then that's going to be times a to the, well, again, we're going to multiply these powers. So negative 2 times negative 3, that's going to give us a positive 6. All right, well then, now we got to use the rule, the first rule we did today, right? So what do we do with the 12 and the 6? We got like bases, right, being multiplied together. We got 2 base A. We got 8 to the 12 times 8 to the 6. So what do we do with the powers there?
Multiply them.
That's when it's a power raised to a power. You got to keep it straight. Like if it looked like this, if it was A to the 12th to the 6th, like that. So if it looked like that, that's when you multiply them. A power raised to a power. See how this only has one base here? But here you got two bases. So you got 2 factors in this product that both have base A. So now what do you do with these powers?
Add them.
Very good. Yeah, you add them. So this would be 12 plus 6. So you end up with A to the 18th power. All right, and then we got one more rule to go. So let me slide down here a little bit. So now we have a product of a number and a variable. So when you look at this example, excuse me, when you look at this example, you got 6x to the 4th, oops, didn't mean to do that. You got 6x to the 4th power. Well, again, if something's to the 4th power, that means times itself 4 times. So you got 6x times 6x times 6x times 6x. But again, we can multiply in any order we want. So we could write this as, this could be 6 times 6 times 6 times 6 times x times x times x times x. So then hopefully you see what we end up with is we end up with 6 to the 4th power times x to the 4th power. So what did we do? Well, when we have a product of 2 factors, we end up putting the exponent or the power onto both of them. So the power goes on the 6, and the power also goes on the x. Now it says, what do we do? How do we describe that? I don't know. I don't know. All right. We're going to put the exponent on each factor. All right, so then I'm going to write a rule for that one. So that would look something like this. If you had A times B to the n power, well then you have to put the n power onto the A and also onto the B. So it would look like that. So let's try these last 3 and we got it. All right, so first thing, let's see on number 9. The first thing you want to note on that one is that negative right there, that second power right there, that is not on the negative. This really means like, this is really like -1 times 2y to the second power. Like that. So that means you're just going to leave that negative sitting out in front of your answer. So you're just going to have a negative out in front. And then you got to put the power onto the 2. So you'd end up with a 2 squared. And then you have to put the power onto the y, so you'd get a y squared. So your final answer, the negative stays out in front, and then 2 squared is 4. And then, well, y to the second power is just y squared. Well, then let's look at how number 10 is different than that then. On number 10, do you guys see that on number 10, the negative is inside the parentheses? Well, that means you're going to have to put the power onto the negative 2. So it's going to look like this. So it's going to be negative 2 to the third power, and then times y to the third power. Well, what's negative 2 to the third power? And again, it's not negative 2 times 3. It's negative 2 times negative 2 times negative 2. What do you think, guys? What's negative 2 times negative 2 times negative 2?
Negative 8.
Good, yeah. Negative 2 times negative 2 would be positive 4 times another negative 2 would be negative 8. Hey, Ethan, you need to turn your camera back on. So we would get negative 8 and then y to the third power. All right, now we just got to do the last one. Ethan, are you there? All right, so this last one, well, the first thing we got to realize is that 3 is to the first power there. Here, let me zoom in on this one a little bit. So that 3 is to the first power. And then, since it's a product of 3 factors, we're going to have to put that second power onto each of these. Like that. So that would look like, well, we'd have 3 to the first power squared. And then we'd have x squared squared. And then we'd have y to the negative 3 squared. So now we got to go back to the second rule we learned today. So you guys, what do we do with these powers now?
Multiply them.
Good, yeah. It's a power raised to a power, right? I mean, if it was like 3 to the first times 3 to the second, then we would add the powers, okay? But since it's a power raised to a power, we multiply them. So we're going to multiply these powers, we're going to multiply these powers, and we're going to multiply these exponents right here. So here we go. So that's going to give us 3 to the 1 times 2, that's 2. And then x, well, that's going to be to the 2 times 2 power, so that's going to be to the 4th times, and then we're going to get y. And then here we're going to multiply these powers. So negative 3 times positive 2, that's going to give us a negative 6. All right. Now we're not quite done, because if you remember Monday's lesson, what do we like to do when the power is negative? In other words, we can't leave a negative exponent in our answer. So again, cameras are off again. Jadis, Vanessa, and Ethan, your cameras need to be on. So what do we like to do when the power is negative? What do we got to do? This is from Monday's lesson.
Remove it.
Yeah. That's why I played you that video. So when there's a negative power, we like to move it. So we have to move it to the denominator, and we have to change the power from negative to positive. So the 3 squared there, that's 9, right? 3 times 3 is 9. So we end up with a 9. The x to the 4th, that stays on the top. Okay, that stays in the numerator. If the power is positive, you leave it where it's at. But if the power is negative, it means we got to move it to the denominator, and we got to change the power from negative to positive. So this is going to be over y to the 6th. Hold on. And there you go. That's your answer for that one. Okay? Let me stop the recording. I think that was it, wasn't it? Yeah, that was the last example.